Hello everyone. This is a problem involving magnetic flux change through a closed loop, and we know that whenever the magnetic flux linked with a closed loop changes, EMF is induced across the loop. And so let us go through the problem once. A uniform magnetic field B equal to 0.25 k cap Tesla exists in a circular region of radius r equal to 5 meter. So a circular region can be seen, and there is a magnetic field of magnitude 0.25 Tesla, and direction of this magnetic field is perpendicular to the xy plane across the positive z direction. And a loop of radius r equal to 5 meter lying in the xy plane encloses the magnetic field completely at t equal to 0. Subsequently, it is pulled at uniform velocity v equal to 4 I cap meter per second. I cap matlab the velocity imparted to the loop is along the x axis, and it is a constant speed. So we have to find the EMF induced in the loop at instantaneously at t equal to 2 seconds. In fact, we have a diagram of this. If the loop moves in the xy plane with a speed 4 meter per second at t equal to 2 seconds, it will move a distance x equal to 4 into 2. So that is equal to 8 meters. So it will move 8 meters. In fact, all the points on this loop will move 8 meters, including its center. So let us say this is the loop, and it will come to this position. So if we mark the center, this was the position of the center initially. Now the center has moved 8 meters. So this is the new position of the center. In fact, let us draw another diagram of this. This was the initial position, and let us say it reaches somewhere here. So center to center distance, if the initial center was C1, finally the center will be at C2, and this distance C1 C2, it will be 8 meters in length. This is the distance moved by the center, in fact all the points on the circle. So now only this part, let us draw it in another color, only this part encloses the magnetic field, and the length that is sweeping the magnetic field instantaneously is this length. This is the length L that is sweeping the magnetic field instantaneously at t equal to 2 seconds. At t equal to 2 seconds, we have to find the EMF induced. So if we are able to calculate this length L, then we can easily use the formula for EMF, that is BLV. So main challenge in this problem is calculating this length L, and if you apply a simple geometry, you can easily calculate this length L. The radius of the circle is 5, so this length will be 5. This length will be 5 meters. And from symmetry we can say that this length up to C1, this will be half of 8 meter. So this will be 4 meter. So from simple geometry, Pythagoras theorem, we can say that this length will be 3 meters. And the length L, let us call this AB. This is a straight line AB. This will be equal to twice into 3 meter. That is equal to 6 meter. And this is the length that is instantaneously sweeping the magnetic field. So induced EMF will be B into, in fact, let us put in the values. The value of B is 0.25 Tesla. Length we have calculated as 6 meter, and speed is 4. So 4 into 0.25 will be 1, and 1 into 6, it will be 6 volt. So 6 volt will be the answer. So instantaneously we have to see what is the length that is sweeping the magnetic field, and this length L is definitely perpendicular to the magnetic field B. So we can directly use BLB. So that is it. So this is a simple problem involving geometry. That is all. I hope you get it.